Hi, I'm Sportster Paul. We're messing with the free Solidworks CAM. It's made by CAMWorks. You get it in 2018, 1920. This is a 20 Solidworks. The problem I have with it, it doesn't have a perpetual license. If you stop paying your Solidworks maintenance, the CAM program stops working. For an upgrade, I think if you upgrade, then it's a perpetual license, $2-3 grand for a professional or a premium, depending which company. And then CAMWorks has a mill product, and that's full 3D. And we'll look at it. Right now, I just started with the part. First video was letting a part automatically be machined or automatically recognized, and it caused all kinds of problems. Second video, we fixed a lot of that, but I still made a ton of mistakes. So I want to go over the horrible things I've done, mostly operator error, although I do get frustrated with new software that I don't understand. First problem, okay, so when you enable this in the add-ins, you know, tools, SolidWorks add-ins, you get these 3 tabs. This is the feature tree that shows the features, not the features you created in when you built the part. These are features that this program, the CAM program, recognizes, holes, pockets, things like that. And whether it uses the SolidWorks features you created, I don't know. Then the middle tab is the operation tree. That has all these operations. You can see I've already generated the toolpath. You can see it going, doing its thing, doing all these. Then the last one, here's the tools. The blue tools aren't used. So it's using this 3/8 flat end mill. It's using a center drill, center drill, drill, center drill, 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 drill. That's a real problem because I've got a manual. I don't have an automatic tool changer. I got to do all this by hand and remeasure and do tool offsets. So one of the goals of this video is going to be get down to 2 tools, 3/8 inch end mill and an 1/8 inch end mill to mill the holes. And it's not just the time and tool change. You can't drill a 1/4 inch hole with the high-speed spindle in my Avid CNC Benchtop Pro. 8,000 RPM is way too fast for a 1/4 inch drill. You might get away with it with this little one here on the side. That's just a little bigger than an 1/8. So maybe you could chuck that in and use a drill there and then come with a mill to do the bigger one. So a couple problems there. The humorous thing, there's a couple places the most important thing. I had a machinist shop owner next to my consulting business in California. He programmed every single part before he quoted. So he could get the exact minutes. He wanted $150 per turning spindle. And so he never got burned because he programmed the part before he even gave them a bid on it. So they hide all the times. So here you go, parameters. This is where we left it, 282 minutes to make the part. If you want to see, this is, once again, we're in the middle, we're in the operations tree. You want to see what one setup does, edit definition, and go to statistics, 141. A setup is, it's in the vise this way, it's in the vise that way, okay? I dragged these off because I have a problem where they reopen in the wrong spot. And then for any given, let's see this contour mill here, edit definition, optimize, go down here for any given tool, for any given tool path. Okay, that's how long it is. It was 4 minutes. And don't close it here like I must have last time. Close it on this monitor, then it'll come back up. So getting those times, here's the huge embarrassing mistake I made. Here's a stock manager. And I talked about how, you know, it doesn't make it easy picking a stock and putting the part inside it. You got to start with the bounding box and build out, and that was goofy. But the real problem is, because I had it set to do tool steel. So no wonder it's taken, at first 700 minutes, and then we took out a lot of excess paths and all the goofy automatic stuff that it wasted time with. Got it down to, what was it now, 280 something? No. It's supposed to be 6061. Aluminum alloy. T6 is a heat treat. So say, I haven't touched the stock size. I had to enter these funny numbers to get it to be even, 2.5, 2. They don't let you type the even numbers in and then put the part inside it. My big mistake was I didn't do it symmetrically. See, I added 20 thousandths here, but not here. And I'm not sure why it only shows 2 significant. It might be a unit setting in SolidWorks. But it's not centered perfectly in the part now. See, there's a little wider there. And this side is same deal. If I get it just right, see, I think it's 70 thousandths or 10 thousandths more there, which means you got to be really careful when you flip this part upside down to machine it from the bottom. Obviously, you can just, with a calculator, increase these significant digits and make it equal, and then the part will be perfectly in the inside of the stock, and you can flip it around and everything will work. Okay, so we're going to say okay. And now we go back, we're in the center, parameters, 282 minutes. Oh, wait a minute, maybe we got to generate toolpaths again. Zing, parameters, 29 minutes. Big difference between machining tool steel. Okay, the other mistake I made that I caught while we were simulating, because you have to, this setup, this little arrow pointing down, see it, this little red arrow there? That means the machine's coming from the top. You've put it in the vise like this. Then in the feature tab here, I always get these confused. Okay, I want to do the bottom first, so I get this round thing so I can chuck it in the vise sideways instead of V-blocks, and then rotate it so that this hole here is straight up. And I'm sorry, I never can run AutoCAD. I can never run SolidWorks the way I want, like this. So when this hole is straight up, then you can come down and do that hole. So you do that last. So mill setup 3 comes before mill setup 2 here, where they're doing this hole. What I forgot to do, and this is one of the clumsy things, I didn't do it here. And I just saw it at the end. So here, I got to go underneath, and so now it does this setup. Hang on. Open them all up. So then the toolpaths will show up as I hover over them. Faces, roughs, contours, drills, center drill, drill. Face the bottom. Face the bottom. Do the outside, do the contour. So, one of the things we fixed is in this rough milling, it went all the way down and hit the vise. So I just went in the feature part here and say, oh no, for this perimeter feature, don't go down so far. As a matter of fact, let's shorten it up a little bit. Oh God. I think that's about halfway down. You got to leave meat down here so you can still hold it in the vise. Then once you cut the top part, all these holes, then you can hold this in the vise. This isn't really a practical part to make in a mill. It's probably a turret lathe part. So, okay. What else? There's something I just thought of. I might want to show you folks. The stock mistake was a huge mistake. So then the next thing is in define machine. Once again, I got to go here. Inch, it's medium duty, but I set it to light. That's because it goes to this technology database they brag about. And there, it should be on this ribbon. When it's stretched out over 2 screens, you can open it on the ribbon, but I can't, because when you go to look at extra stuff on the ribbon, it ain't there. So let's go Tools, SolidWorks CAM, Technology Database. I built all these. Delete it. Well, maybe it won't let me delete it. Oh, because it's default. Yes. See, they call it a record. Mill inch. Default machine. Save. Okay. Go here. Delete it. Okay. I want to do this by hand, and it got confusing when I practiced. This is about the 3rd time I'm trying this. So the theory, this is the way it comes. This is as installed. So in theory, you go copy, creates this, then you make this new one the default machine. Machine name is what's going to show up, Avid CNC. Machine ID, I don't know what to call it here, Bench Top Pro. Description, prototype. I'm making all these machine. Making all these different just so we can see what ends up. Post processor. It is a Mach 3. This G54 Mach 3, that has to do with work offsets. I'm not sure. I have Mach 4, right? They don't give you a Mach 4 post. So let's say Mach 3. It's a gantry mill, Avid. So there, this stuff doesn't matter too much. The output multiple parts, if you have a pallet, this is saying, okay, it picks a tool. It does all 4 parts on your pallet if you got 4 parts. If you do features, it'll do one whole feature, then as many tools as it needs, then do the other. I'm not going to do that. I don't care. So we can close. Oh, come on, Paul. Here. It's a 30 horsepower machine by default. So I think I got a 3 horsepower. Index time doesn't have an indexer. Indexing, none. 4th and 5, nothing moves together. Maximum feed rate is 200. I looked this up. Rapid feed rate is 200. I looked it up. I'll have to do a research project to figure out what these accelerations are supposed to be. The table travel in X, it's 24. In Y, it's 37. In Z, it's 6. I think this will help you if you put in too big a part or if you'd run it off the end. I think they're smart enough to warn you. So what else? Turret, none of this matters. Sequential to, it doesn't matter. Spindle, this matters. When it defaulted, when the part was built with this, I tried to set 24,000, see how fast I could push this, kept going back to 12. That's because this was 12,000. I can't get these to work. I don't know what's going on. I click on this. Maybe it's these dialog boxes open up in mystery land. I don't know. Setup, indexing none. Yeah, this is all like multi-axis. I just got a 3-axis mill. And you say save, and what was up there, Avid CNC, and it's now the default, which is cool. Close the technology database. Go define machine. It opens up here. This is still, because I built the part with the default stuff, set Avid, and it's kind of goofy. This is where all that information comes. It wrote here. Although Avid CNC, machine name is what shows up in the list. Say select, because it's kind of goofy the way it works. Now I've selected it, and you saw it kind of think. Don't close it here, because then it'll open in the non-existent monitor. Let's generate toolpaths. It's thinking. Let's go to the middle tab and say parameters 29. Okay. That's good to know. So we messed with the machine to be more realistic, and that can help. Now the tool crib. Over here, the 3rd tab is the tools. And the blue tools aren't used because of the way it automatically featured and the way stuff is going. But to me, it keeps this tool crib just by the part. So it's not like if you change that technology database, it changed this. Although when I did add a tool to the technology database, like this, I had to add this 1/8 inch so it would do this little set screw hole here. And then figured, update all tools from technology. It doesn't take what's in the tech database and put it in this one. Very confusing. So what I'm going to do, let's double click on this. Once again, it's one of these. Let's go tool, let's select. Now, when I said prompt, you're going to put the tools you're using in the empty tool crib, just so it's less cluttered. I'm anal this way. I tried prompt, it didn't do anything. So let's say auto. Now, just the tools that were used are here in tool crib 1, and that's where we are. So we say, okay. And it says tool crib 1, and now it's just got those parts and the stations. I assume these tool numbers, that's what the G code's going to call. That's what your tool holder better have, although I'm manual. So I really don't care about the order and what's TO1 and how you change these, how you order them, update, save, new tool, properties, expand, collapse. I don't know. It's dialog box hell. So we've got the tool crib. Here's something I forgot last time, kind of embarrassing. Go to the middle tab, which is the operations. I set it up so it does the facing, it does all this, it does the drills, does all this, then it does this setup. When I made a part, I made this little test angle iron part. I wanted to do both sides. I programmed it. Doesn't stop the mill automatically. A setup does not do that. So you got to go to the last thing you did before this setup, You right-click and you say, don't say post-process, you say post-operation. The only operation that lets you choose is stop the program. Insert that. Close. So now it's going to stop and give you a chance to put the part in the vise. Doesn't stop the spindle from rotating, danger. Doesn't move the spindle out of the way. How that all is going to work, I'll let you know. You know, I'm sure I can turn the spindle off and turn it back on, but it's kind of disappointing. It doesn't help you a little more and understand, hey, I'm doing setups. Post-operation, insert, close. Now, obviously with a manual tool changer, I'm going to have to put stops here. And when it posts, I'm not sure if this thing asks for the tool change. I haven't found where to say, I don't have a tool changer. You know, I got to change the tools by hand. So first thing, because of this high-speed spindle, 8,000 RPM is as slow as I can go. I can't do this big drill. The surface feet per minute at the corner of the flutes is way too high. I can't even do a 1/4 inch end mill. Nobody can with an 8,000 RPM. It's a big problem. Some folks just mount a hand drill on their gantry, and you know, when they're done milling, they take this hand drill and use the CNC to run it down. I'll show you how to change these over to pockets. In other words, you route them out, including this tiny little one. So that's going to be fun. Let's see if we can get this done. Where do I want to start? I know here, come on, hole here. I'm going to delete that because I tried, drag the tool from the drills to the delete. Yes. So we took these holes. Don't accidentally hit extract features. It'll put them back in. And then see what's strange if you say generate operation plan. Let's regenerate from scratch. And I'm curious now if over here, because it wasn't doing it before. Oh, and then generate tool paths. So it moved the post operation to the top. See, this is the kind of infuriating stuff. Okay, first problem, instantaneous first problem. Okay, so it does the face mill, does the rough, does the contour. It's using the 1/8 inch to do these. Genius. And then it doesn't do the holes because it didn't see them. When I did it the first time, I just jumped over here without regenerating the, what do you call it, the operation plan. It's smart enough to know since it didn't have the features, it took out the features. So, do you like taking problems on one at a time? What the heck is this? Oh, it used the face mill again. Boy, that must be a heck of a face mill. So let's go to our tools. Tool crib 1. These are the tools, okay. Face mill, here it is. Face mill, must be a big T10, 3, I think, oh, it's a 3-inch face mill. Good God. So I want that to be a 3/8. And I want this to be a 3/8. This is what's pretty cool, right? This is when you start to love the program. Boom, automatic, did it. Then this face mill turns blue because it doesn't use those tools. Next thing is using that and this 1/8 inch end mill, we want to do the rest of the stuff. Sorry, I keep opening stuff. So we've created, now we go back and we make these not, don't call them holes. You do, okay, we're mill part setup 1. What do you want to do? The big one first, the little ones? Let's leave the meat in the middle of the thing. 2-axis feature, make it a pocket. Everything seems to be not where you want it here. This, this, 6 loops. Not done yet, because it doesn't know, it knows that's where the edge of the pocket, end condition. It just happens to be doing them blind based on that, and this could be for me playing with this thing. I don't want it that much over. I want it to go under the surface a little so that it doesn't leave a sharp burr there. But rather than 49, let's just make it 42. And there. That's just enough to clean that up. Say, okay. Then the next one, mill part setup, 2.5 axis feature, pocket. This, let's see if it added it. Yes. End condition. Now we want to go blind. This always seems to work backwards for me. Oops, I'm sorry. Let's get here and let's go up. Oops. Same thing, just a little bit below, because we're going to come face that off afterwards and we want it to have a nice crisp edge. So we're done with that. So now we're in the feature tab. We got these two blue features because we haven't gone and generated an operation plan. Rather than just go nuts, let's do them individually. Generate operation plan. Did it. Turned from blue to black. Generate operation plan. Did it. Now let's see what it did. Rough mill. See, it's using the same. Oh, no. This is actually smart. It finally acted the way I wanted. For the little holes, it uses the 1/8 inch. For the big holes, it uses this. Say generate toolpath, boom. Rough and finish. I spent a lot of time. Oh no, I don't want to rough and finish. I just want to spiral down. It ran away from me. It'll be 5 hours to show you trying to take lead-ins and gouges and all these problems I had. So let's just do that. What's next? Face mill. Look, it's rough milling with the 1/8 inch. What is wrong with... So, where is it? 1/8 inch flat end. Come on, open it up. Rough mill. You don't want that. Drag it up here. Contour mill. You don't want that. Drag it up to the 3/8. Good. Rough mill. No, that's the one you want. That's the one you... Or no, wait. It's so easy to get confused here. Rough mill. See, something's already wrong, I can tell. I've done something bad here. Contour mill. Rough mill. That's correct. Contour. Draw this up here. Flat end. And... So let's see if it makes sense. See, this is the problem I have. Oh, good Lord. Here. I think it's acting. Why is this blue now? That's cause for concern. Why did it turn blue? Okay, contour mill, flat end, generate toolpath. I guess it doesn't have to do a contour mill anymore. This is where I get so confused. Empty the recycle bin of those holes. Yes. Okay. Face, perimeter, little holes, big hole. So this is this. Oh, wait a minute. I'm screwing up. This is this guy. Now how do you figure out which tool this is? See, I can never figure out what light stuff when you hover, when it's constantly confusing me. What I should see, well, oh no, I know the solution. Hang on, we're not done yet. Because here, this counterbore hole, we're going to erase that too, because we want to mill it. We don't want to do they use like 5 operations. Remove. Yes. And mill part setup 2, let's do this. 2.5 axis feature, a pocket. I want to pocket this thing. The end condition. See, it's doing that blind. Get close. I want, not blind, you got to go pick up to face, and this is the face I want. And see, now it's doing its thing. You say yes, wonderful. Then mill part setup 2, 2.5 axis feature. Now I want to do this. End condition. Now it's still blind. It seems to like doing blind stuff, but that might have been me messing around. There. Good. Now say generate operation plan. generate operation plan, come here. Well, this one I just go nuts and say generate toolpath. Now, this is where it's showing you. I messed up. See, I wanted to spiral cut these. I didn't want to plunge and turn. And this little red thing and the fact that it's blue saying, hey, it didn't do something. So I won't even waste your time showing you simulation. 25 minutes. Let's see how we're doing. What's wrong? Unable to compute safe lead-in or lead-out move. Disable gouge check and define lead-in or lead-out manually. Notice they have all this space here and they don't tell you where you disable gouge check. Well, trip to the internet tells you. What do? You double click it. Up comes operation parameters, which I got to drag on. You go to lead-in, you go to gouge check off, and if you just do this, then, if you say, okay, gouge check is off, then say, what, okay. Then say generate toolpath. It turns black and you think you're okay, but go look at this thing. When you machine this part, you'll see that it puts a big giant gouge in there because it's doing lead-ins. What it's trying to machine is this tiny little circular thing. And I don't have time in this thing to show you all the goofing around to make a spiral and deal with this. I don't know that it needs lead-ins or lead-outs. Probably would just chuck an 1/8 inch drill and then clean it up. But go back to this goofy thing where we were, lead-in type, say none. Drag it off because of my monitor problem, say okay. And now it just spirals. Well, it doesn't spiral, it plunges. If you want to try seeing what a spiral looks like, double click on it, opens up. That was lead-in, lead-out. Now you go to contour, ramp, angle. Oh, here's something confusing. Confused me at least. Say preview. Oh, you can't see this because it's off the screen. All kinds of dialog box weirdness because of my monitor setup. You say preview. So I'm going to do that, but I'm going to drag it back so you can see the whole box. I can see the bottom because it's a 1200 monitor. Preview. And then you, okay, yeah, I did what I wanted. And then you're looking, what? Oh, it collapsed it and made this into here. So then you do tool again and it reappears. I have to drag it off, just me. Say, okay. And there you go. Now it's a spiral. Taking very little cuts. It's probably not deep, fast enough cutting. It'll probably burn the tool up. So there's a broken end mill. But that, don't blame the program. I mean, you're expected to know speeds and feeds and stuff like that. Next thing, speaking of speeds and feeds, let's go look at some of these. I think, let's go look at our tool. See, now I like this. All of these tools are unused. Delete them. Yes, passive aggressive. Delete. Yes, passive aggressive. Now, there's just two tools. A 3/8 end mill and an 1/8 inch end mill. That, when you have to do the tools yourself, and because of this speed problem, right? The surface feet per minute. Although I should tell you, do I have it? I don't have it handy. Destiny Tool says, you can go max RPM with some of their end mills, like their Viper brand, in aluminum. So there's going to be plenty in the coming weeks and months. There's going to be plenty of playing around, seeing how fast I can push stuff in this, router style aluminum machine. What did I want to show you folks? Okay, part setup. Did we do our stops or have we lost that because we regenerated something? Post operation. Yeah, see, move it down here. Post operation. Move this. Okay, that stayed where it was. Okay, and up here, we've got to do a little bit of work here and here. These two, rough mill, control, contour mill, drag those down right here. So rough, contour, and then here, do post-operation insert. Did it do it? So now it's using the 3/8 end mill down to here. Then to do the little ones, you got to put an 1/8 inch. Then because just to hold apart, you got to go back to the 3/8, do this stuff. Then do the rough contour. Like I say, I tried to do the spiral. We don't have enough time to watch me mess with that. That could be a whole video in itself. Just in case, I like to generate toolpaths, parameters, 25 minutes. Not bad. When I played around with spiral and stuff, I got it down to 8 minutes once, which is probably too good to be true, but I took out roughing operations. The Viper end mill, the Destiny tool end mill, says, oh, you can rough with it. You can cut plastic, you could cut steel, you can cut aluminum. They're pretty cool. So now what? Let's show you face mill. Double click. Feeds and speeds. So the spindle's doing 14,000. This is something to do with the library. The spindle says 14,000. All I've learned is if you go by operation, you can now change these. If you go down to what the tool, something in the technology database, they call for that tool, it goes down to 7,000 RPM, 697 surface feet. Go back to library, and just so you can see it better, I'll light it up. That's pretty honking, right? I like that. So we'll leave it there. Oh, don't close it here. Okay. Same thing, rough mill, I'll check. See, the rough mill, they're going slow because it's a rough mill. Sorry. Operation. And this is something that didn't show right on the second video. 12,000 RPM. Now your feed rates are what you'd expect. Or I'm sorry, your surface feet per minute. Oh, that's what I got to show. The feed rates, because when I was practicing, I don't know if it'll happen now, it wanted a feed rate over, I raised it. Oh, that's what I did. Why am I going 12? Let's go 24. And come here. Now the feed rate's up to 91. Surface feet per minute's 2,000. Yeah, that's getting a little too fast. We'll stay where the conservative settings were. All right. Say okay. I'm just going to go through these. Feeds and speeds. Once again, slow. We don't like slow. We like fast. Let's do 12,000. See where we are. Don't hit enter. About 1,000 feet per surface feet per minute. That's good. Say okay. Since we're speeding things up, I think that's going to work out good. Rough mill. Yeah, this is another slow one. See, my spindle will barely do this. 8,000 RPM, 30 inches a minute. Let's do 12,000. 1,000. One of the times I went 24 here, maybe one of the little tools, the 1/8 inch tool, and it made the feed rate, it warned me, it said, hey, your machine can only go 200 inches. You type that in, this is the technology database helping you. So I'll just go 200 because I can't go fast enough, which can be a problem. Then you don't have enough chip load. You're not taking big enough chips. Contour mill. This is a slow one. So let's go operations. Let's bump this one up. What was it? 29 minutes total? 12,000. And say, see, don't hit OK. Just, that all looks reasonable, right? Draw this over. Say OK. Post-operation. So this is the... Oh, it's smart enough to go 24,000 RPM. The feed rate's 139. I'll light it up just so you can see it. That's pretty cool. I wouldn't try my first cuts like this. And it's an 1/8 inch end mill. Fast doesn't always hurt you. Okay, don't close it here. We'll go through that goofiness again. 35 minutes. I do want to... 24,000 for that one. I'm just going to... okay, now we're coming from underneath. This was doing 14,000. Well, we'll definitely leave that. Rough mill. 7,000. From library to operation. Don't hit enter without pulling it off the screen. Contour mill. Same thing, 8,000 RPM. No, faster you can remove material. Did I do my rant about torque and horsepower? Even my beloved Destiny tool says, it's not horsepower, it's the torque. Well, the horsepower is how fast you can remove chips. And if you're a shop owner who cares about money, you want to remove chips as fast as you can. And if you're a old coot like me, going to die soon, you want to remove chips as fast as you can. As long as you got a constant torque spindle and not a constant horsepower spindle, you want to go as fast as you can and then think back, well, will I speed will the tool take it, right? Rough mill, 24,000. These are the little 1/8 inch. So these are all going to be 24,000. See, this is where the technology database and me setting this up, taking that little bit of time. So new to the program, new to machining, new to CAM. Okay, so let's do toolpath just in case it has to rethink of stuff. Parameters, 24 minutes. See, those little bit of humping we did, we actually sped this thing up. Now you're close enough here. You can go simulate toolpath. The warnings here, tool pause on collision. Back when I tried to do spiral stuff, it was pausing and darned if I could figure out. But I was also gouging that. That you want to pause. You don't want to cut it, although you could and see what's wrong. You certainly don't ignore it. Now I know that these tools are still too short and I don't want to cut it and ruin the part or pause. Just ignore it. The middle one is the tool shoulder shank. This one is the tool holder, and it's set, once again, to ignore collision. Let's go wicked fast. Get back a little so you can see. And go. There's a 3/8 end mill. You should obviously take almost as much time watching this. Goes down there, so now you can flip it over, and it's doing the finish cut here. Now you can grab it, turn it upside down and grab it. You see it buried the tool, but that's okay. Finish. Here's, I think, the rough with the 1/8 inch end mill. So it's pause, it let us change the end mill. You got to find tool offsets and all that business. There's a whole science. That's a couple videos alone. Right now, I just want to get familiar with the CAM package. And I know I'm not going to use the free version because it expires if I stop paying my maintenance on Solidworks. So now it's doing that. Now it's doing the finish. And now it's doing that little 1/8 inch here. There's that tiny little spiral that I put in. And this one buries, you know, I got to make the tools all longer, which of course makes them break more. But now, display options, if it's green, it's good. If it's blue, it didn't get cut. If it's brown or red, you know, that means it's gouged. So, how'd this look in here? Beautiful, beautiful. Look at from underneath, beautiful. So now we have something that just uses two tools. I can use it in my Avid CNC. Let's put a, there's one of the roughing passes. Okay, so getting more and more familiar with it. It still seems like it's fighting me, but see, that's because I'm new to both machining and to CAM packages in general, and this particular one. I'm suffering more with this one because it's the first one. When I try Bobcat, and you know, I'll go through, I think it's worth a video, we'll make a video of that. For now, it's already 40 minutes. Sorry to take so long. Next video will be a test part a buddy made, my buddy Dave Rui in Silicon Valley, that, you know, he said, well, this chokes a lot of CAM packages, you know, maybe an old version of Mastercam or something. He said he built it. And we'll watch what CAMWorks equal to Solidworks CAM does with that. It does the same screw ups with automatic feature stuff, but getting more familiar, we'll see, and we'll see if we can turn on Volume Mill, which is this third-party thing that they adaptive machine goes real high speed. That'll be fun to see if we can speed it up that way. And I'll practice a little more so that I don't waste your time. Sorry this is so long. Good luck with your CAM projects. I'll see you next time.